Hello, we are the Genesis generators, and this is our project, Stroke Prediction. First of all, about our project. Our project uses a data set about stroke prediction acquired from Kaggle to predict the chances of getting a stroke. For this prediction, our program utilizes a person's gender, age, marital and smoking status, presence of heart disease or hypertension, work and residence type, BMI, and average glucose level. So all those kind of things. Motivation. So in the United States, every 40 seconds, someone has a stroke. And every 3.5 minutes, someone dies of a stroke. 1 in 4 people over the age of 25 in the world will experience a stroke. For people who go to the emergency room within 3 hours of the stroke, they're much more likely to avoid serious disability. Our project is aimed at helping those people, especially in the healthcare industry, identify if someone has a high risk of a stroke so they can spot warning signs, symptoms of a stroke and access treatment quicker. Thank you.
So our MVP, a minimal viable project, is in 3 weeks. Our final project will have accomplished complete analysis of characteristics that result in stroke, and our product will be able to make accurate predictions whether a person will encounter a stroke in the near future based on these characteristics. Tech stack. Tech we will need in order to create our project. This project uses HTML, CSS, Bootstrap for the front-end development and website creation. Along with these coding languages, we have used Python as our backbone. We used Pandas for data management, NumPy for mathematical operations, sklearn for machine learning, and Plotly for generating our interactive plots. Thank you.
So here we have the graphs that we've created over these past 3 weeks. We have here our bar graphs that show our different factors that we've been analyzing, such as gender, hypertension, heart disease, marriage, work type, residence type, and smoking status. We found that the two groups of people that had the highest correlation for strokes were marriage and work type, specifically married people and people working in the private sector. These are our pie charts. We have the pie chart representing heart disease. We can see that 80% of people who had strokes did not have heart disease. 60% of people who had strokes worked in the private sector. And we can see that residence type didn't really affect stroke by that much, split pretty much down the middle. We have another bar graph here, which shows the correlation between residence type, BMI category, and also age group. You can see that the age group that has the highest correlation with stroke is people in their 70s. We can also see that the more overweight people are, the more likely they are to have a stroke. This collection of graphs depicts the relationships between BMI, heart disease, residence, and strokes. Overall, there's a negative correlation between heart disease and strokes. However, with BMI, there's a positive correlation. Interestingly, people who never smoked have the highest rate of strokes, with people who are currently smoking having the lowest. Finally, overall, there was a slightly higher rate of strokes in people with urban residences, but there are also many cases where this is flipped. This is our scatter plot. It shows the correlation between BMI and age. There's a very weak positive correlation between BMI and age, but there's a lot of outliers, so scatter plot's not entirely reliable. This is our box plot, which shows the different averages of glucose level compared to BMI. We can see that the class that has the highest, the age group that has the highest average glucose level is people in their 30s that are underweight with a median of 167.16. This is our correlation heat map, which shows the strength of correlation between all the factors that we studied. So the lighter the category, the lighter the box, the stronger the correlation. Our two factors that have the strongest correlation are BMI and age, with a correlation of 0.33. And finally, we have our final bar graph, which shows the correlation between BMI and age group for total strokes. And once again, you can see that people in their 70s are more likely to have strokes, while people that are also more overweight also have a higher chance to get a stroke.
So the process, how we turn data into information and information into insight. So for week 1, we were introduced to data science and data analytics, and we learned about the basics of Python. We also chose our data set for our project. And then for week 2, we cleaned and analyzed our data, and we also learned about machine learning models and started implementing various classification models from sklearn and checking for the accuracy. And then in week 3, we learned about HTML and CSS, and we started front-end development to create our website.
For the actual machine learning part, there were 2 really big questions we had to ask at the beginning, which was regression or classification, and then is this a supervised or unsupervised model? And we ended up deciding that it's a classification problem and it is an example of supervised machine learning. We ended up testing out 11 different models and found that our 3 best ones were KNN, SVC, and logistic regression. We also ran a bunch of hyperparameters on these 3 models to find the best version of them. So for the KNN model, we specified n neighbors and leaf size to be 10. For the logistic regression model, we specified solver is equal to liblinear and random state is equal to 0. And then for the SVC model, we specified kernel is equal to linear. And then for the comparisons, we were working with accuracy and mean standard error. Accuracy is calculated by that equation, and you want accuracy to be as close to 1 as possible for the best model, which we saw like KNN was really close to 1. And then for mean standard error, it's calculated by taking the distance of points to the regression line and squaring them. It gives us the average of a set of errors, and we want that to be as close to 0 as possible. And we saw that KNN was really close to 0, so we came to the conclusion that KNN would be the best model for us.
So for our conclusion, our results show that the variables in our data set that have a positive correlation with stroke includes females, people with no heart disease, people who work in the private sector, people with hypertension, people who have never smoked, people who are older in age, people who are married, people who live in the urban residence, and people with a slightly higher body mass index. These variables indicate that a person may be at an increased risk for getting a stroke. We evaluated that the most accurate machine learning model that resulted in the lowest mean squared error was K nearest neighbors. We hope that our findings will help in aiding the healthcare industry with the prediction and classification of strokes. Thank you.